So where we left off last week, Wednesday, we were talking about these mixture problems. So I want to make sure we hit those a little bit for review here. So the type of problems we really want to look at is how much 28% solution should be mixed with 240 milliliters of 43% solution to create 37% solution. Okay, so remember the deal here was we had two ingredients, two inputs. And so we need to get those and what they're containing, the amount of solute they contain, and that has to equal the amount of solute in our final ingredient. So here we are mixing 28% and 43% solutions. And we're combining those in an effort to make 37%. Now we need to know how much of each of these. So of the 28%, we're trying to find how much. So that's our X, what we're trying to find. Should be mixed with 240 milliliters of 43%. So that's 240 milliliters. Now remember, one of our things that is constant in these situations is the total volume of solution. So if I add those together, that has to equal the total volume of the 37% solution. So the volume of the 37% is just X plus 240. Now that we have all that down, we can write our equation for the amount of solute. So the amount of solute has to be equal to from the ingredients to the final solution. And remember, that was the concentration times the volume. So here 28% is 0.28 times a volume of X. Plus, here 43% is a concentration of 0.43 times a volume of 240. And so then the solute from those two ingredients has to add together to equal the solute in the final solution. 37% is 0.37 times a volume of X plus 240. So now we have to solve the equation. And our first step is to combine on either side. So on the left side here, 0.28 times X is just 0.28X. 0.43 times 240 is 103.2. Equals, on the other side, 0.37 times X is just 0.37X. And 0.37 times 240 is 88.8. Now we've combined everything that we can combine. The next step is to make sure we have the variable on just one side. Right now it's on both sides. So we will get rid of it on the left side. The smaller variable is the 0.28x. It's positive, so we're going to subtract 0.28x. Remembering that we have to subtract 0.28x from the other side. And again, the only place we can subtract that is from another x. So on the left here, the 0.28 is gone. We have 103.2. On the right side, 0.37x minus 0.28x is 0.09x plus 88.8. Now we are ready to start solving this equation. So we'll go ahead and subtract 88.8. So 103 minus 88.8, I believe, is 14.2. $15.2, sorry. Is that correct? Nope, it's not. 14.4 is what it should be. Nope. Math, right? Then we have to divide by the 0.09. That's gone. We have x equals 14.4 divided by 0.09 is 160. So as always then, after these word problems, we have to go back and make sure we know what x stands for. Go back here. X is the amount of the 28% solution. That's 160 milliliters. Then we have to make sure we've answered the question. We'll ask how much 28% solution is needed. That's exactly what we just answered. So we have answered our question. So we're good there. Anybody have any questions on these mixture problems? I know some people can get buried in writing the equations. So then our next step, well, let's just review just for a second. So remember, when we're solving an equation, there are two things that have to be done or looked at before we actually start to solve. And of course, the first is to combine on each side. So in the problem we just did, this was multiplying or combining like terms if we had them, doing any distributing that's necessary, combining whatever we can on each side of the equation separately. The second thing that had to be done before we could solve was make sure the variable is on only one side. So up here, that was getting rid of the 0.28x on one side so the variable is on only one side of the equation. Then we can go ahead and solve. Now today we're going to continue working with some equations, but we're going to take it to the next level, adding in fractions to our equations. We've seen something like this. X over 7 equals 5. This notation here looks like a fraction, but we know that it's just division. There's a relationship between division and fractions where we can very quickly switch from one to the other. So to get rid of that 7, we multiply by 7 on both sides. That gets rid of the dividing by 7. X equals 35. But if we put in something like this, x over 3 plus x over, x over 8 equals 33. Now, x has been divided by two different things. Can't just multiply by one of them and make it go away. But there are similarities here between this and something like 2x plus 5x equals 21. In a problem like this, we just combined 2x and 5x. 2 plus 5 is 7. That made 7x. Well, over here, there's similar things we can do. First of all, we know that x divided by 3 is equivalent to 1/3 times x. Remember when we did our fractions, multiplying by the reciprocal is the same as dividing by the number. So instead of x divided by 3, I can write this as 1/3 x. So then x divided by 8 would be the same as 1/8 x equals 33. From there, then, we can do exactly what we did over here. We can combine the like terms. 1/3 x plus 1/8 x. Well, we do have to add the 1/3 plus the 1/8. Need a common denominator. It's going to be 24. 3 times 8 makes 24, so 1 times 8 is 8/24. 8 times 3 makes 24, so 1 times 3 is 3 24ths, making 11 24ths. So 1/3 plus 1/8 is 11 24ths. So 1/3 x plus 1/8 x is 11 24ths x. Exactly the same as we did over here, just the math was more complex because we had to do it with the fractions. Equals 33. And now we have to divide by the 11 24ths. So over here, the 11 24ths divides out, we're left with just x. Over here, this 33 divided by 11 24ths. Now I purposely wrote it like this in that fraction notation because some students find that confusing. So I wanted to make sure we looked that over. So 33 divided by 11 24ths, I could write it like this, which would make a lot more sense to most students. So I have to make the 33 into a fraction. That becomes 33 over 1. That becomes 33 over 1 times the reciprocal, times 24 over 11. Now we can reduce. 33 and 11 both can be divided by 11. 11 divided by 11 is 1. 33 divided by 11 is 3. And now we multiply. 3 times 24 is 72. 1 times 1 is 1. So 72 over 1 or just 72. X equals 72. There's another way to go about that problem that we'll come back and look at in a little bit. But for now, let's keep going with these fractions. So we might have something like 2/3 x plus 3 1/8 equals 5 1/2. Again, this is no different than having an equation like 2x plus 5 equals 11, where we would subtract the 5 and then divide by 2. The only thing different is we're dealing with fractions, so the calculation is going to be a little more difficult. With this one, we probably could do the calculations in our head. Over here, we're going to have to probably write them out or use the fraction calculator. So anyway, our first step over here, again, there's nothing to combine on each side, and the variable is already on one side. So we can go ahead and start to solve. We'll subtract 3 1/8 from both sides. So the 3 1/8 is gone. We have 2/3 x equals 5 1/2 minus 3 1/8. Well, this will be 5 4/8 minus 3 1/8. So 8 is our common denominator. We subtract 4 minus 1 is 3/8. 5 minus 3 is 2, so it's 2 3/8. And then we divide by the 2/3. X equals, so once again we have to do that division. 2 3/8 divided by 2/3. Well, 2 3/8 needs to become improper fraction. So 2 times 8 is 16, plus 3 is 19/8. Then we're going to multiply by the reciprocal, so 3 over 2. Nothing reduces here, so we just multiply. 19 times 3 is 57. 8 times 2 is 16. And we divide. 57 divided by 16. 16 goes into 57 3 times. 3 times 16 is 48, so there's 9 left over. That is 3 9/16. We could end up with equations that are more complex, like this. We might have 1 1/2 x minus 3 3/4 equals 1/3 x plus 2 5/8. So again, we have to go through the process. There's nothing to combine on either side, but we do have x on each side. So we have to get x on one side. Smaller one is the 1/3 x, so I'm going to subtract 1/3 x. So now on this left side, I have 1 1/2 x minus 1/3 x, which is 1 1/2 minus 1/3. Common denominator there is going to be 6. 1/3 is 2 6, 1/2 is 3 6. Subtract 3 minus 1 is 1/6. And then we have the 1. So that's 1 1/6 x, minus the 3 3/4. On the right side, the 1/3 x is gone. We just have the 2 5/8. Now we can solve. We're going to add the 3 3/4. So on the left side, that's gone. We have 1 1/6 x equals. On the right side, we still need a common denominator. It's going to be 8. So the 2 5/8 stays the same. 3/4 becomes 6/8. And then we'll add. 5 6 is 11/8, which is 1 3/8. So we'll keep the 3/8 and carry the 1. 1, 2, 3 makes 6. 6 3/8. And finally, we have to divide by the 1 1/6. X equals 6 3/8 divided by 1 1/6. So first, we're going to change those into improper fractions. 6 times 8 is 48, plus 3 is 51/8. Divided by 1 times 6 is 6, plus 1 is 7/6. Then we have to change it to multiplying by the reciprocal. So the 51/8 doesn't change. Remember, division operates on the fraction coming after it. So this is times, the reciprocal would be 6/7. We can still cross cancel here. 8 and 6 divide by 2, giving me 4 and 3. 51 times 3 is 150. 4 times 7 is 28. And now we have to bring that down from 153/28 into a mixed number. The 28 goes into 153. Let's try 5 times. 5 times 28 is 140. There's 13 left over. So it's 5 and 13 28ths. So you can see solving these equations with fractions in them is exactly the same as solving any other equation. It's just uglier because the calculations involve fractions. We can't do the calculations in our head anymore. Well, let's go back to that x/3 plus x/8 equals 33. There was a second way we could have approached that problem. We could have looked for a least common denominator. When we talked about fraction factoring, that was the least common multiple. Same thing. So here we have denominators of 3 and 8. The least common denominator of 3 and 8 would be 24. Remember, one of our rules of equations is we can multiply both sides by the same number, and it doesn't change the equation. So I can multiply this side of the equation by 24 and this side of the equation by 24. And it shouldn't affect the results of the equation. So on the left side here, we have 24 times x/3. So right, that's 24/1 times x/3. Well, 24 times x is 24x. 1 times 3 is 3. 24x divided by 3 is 8x. Then we have 24 times x/8. So again, we write it as 24/1 times x/8. 24 times x is 24x. 1 times 8 is 8. 24x divided by 8 is 3x. Equals, well, over here we have 33 times 24, which comes out to be 792, I believe. Let me double check that. $792 is correct. And now we can solve this. We have to combine on the left side here, 8x and 3x, like 11x, equals 792. And we divide by 11. X equals 792 divided by 11 is 72. Same answer we had up here. Right up here. Now, some people find this easier to do using the common denominator, multiplying it out. In a problem like this, it probably is a little bit easier. Other people really struggle with it. You know, something like similar to that second equation where we had 2/3 x plus 2 1/8 equals 5.5. Finding a common denominator there, least common denominator. When we have denominators of 3, 8, and 2. Well, the 2 isn't going to affect anything here because anything that the 8 goes into, 2 is also going to go into. So for 3 and 8, it's 24, and 24 will go into, 2 will go into 24 as well. So we'd multiply both sides by 24 again. So on the right side here, we have 24 times 2/3 x, 24 over 1 times, now 2/3 x, I'm going to write the x on top. 2x over 3 is equivalent to 2/3 x. Think of that as x over 1, so it's 2 times x and 3 times 1. So I have 24 times 2x is 48x. 1 times 3 is 3. 48x divided by 3 is 16x. Then we have 24 times 2 1/8. 24 over 1 times 2 1/8. Well, we need to make this improper. So this will be 24 over 1 times 2 times 8 is 16 plus 1 is 17/8. And here I would cross cancel. 8 and 24 divided by 8 giving me 1 and 3. 3 times 17 is 51 over 1. That's just 51. Equals 5.5 times 24. First, I would make that 24 over 1, so it's a fraction. 5.5, 5 times 2 is 10, plus 1 is 11 halves, times 24 over 1. 2 and the 24 cross cancel, giving me 12 and 1. 11 times 12 is 132 over 1. This is 132. Now we can solve this like any of our other equations. Subtracting 51. 16x equals 81. Is that right? Something's off. Oh, that's right. And then dividing by 16. X equals, now remember this is a trick we showed you last week. If I'm solving an equation, I'm dividing by something that doesn't divide out evenly. Remember, you can turn that division into a fraction. Instead of 81 divided by 16, we can treat that as 81 over 16 and just reduce it as a mixed number. 16 goes into 81 5 times. 5 times 16 is 80. There's 1 left over. That is 5 and 1/16. Again, the same answer we had up above, just a different approach. Now, some people prefer this over working with the fractions throughout the whole equation. Others find this process of doing that initial multiplication is confusing. It does take more steps. So I warn you, be very, very careful as you try that process. There are some equations where we don't have a choice. It's really almost impossible to solve them without using that least common denominator. Those equations might look like this. 2x minus 3 over 7 plus 5x plus 1 over 3 equals 3x plus 4 over 7. So something like this, it would be really tough to solve this without using that least common multiple, least common denominator, and getting rid of the fractions. The only way you can do it is you actually distribute division just like you can distribute multiplication. So this here, 2x minus 3 over 7, would become, you divide the 2x by 7, become 2/7 x, minus, you do the negative 3 divided by 7, so it would be minus 3/7. Well, that just makes even more fractions that we would have to work with in the process. So here it's way easier to just go through and get rid of the fractions. Our least common denominator here, we have denominators of 7, 3, and 7, so just 7 and 3. That's going to be 21. So I can multiply both sides of this by 21. So on the left side here, 21 times 2x minus 3 over 7. Make that 21 over 1 times 2x minus 3 over 7. Now, one thing to remember here is this fraction bar is an enclosing symbol. Think of it as having parentheses around the top and the bottom if there's multiple digits. Well, the bottom is just a 7, so we don't need parentheses there. But we do need the parentheses around the 2x minus 3. Now, I would cross cancel. We have 21 and 7 both divide by 7 to give us 1 and 3. And then we distribute the 3. 3 times 2x is 6x. 3 times negative 3 is negative 9. Moving on then to the next part. 21 times the 5x plus 1 over 3. So this is 21 over 1 times 5x plus 1 over 3. Once again, I'll put parentheses around the 5x plus 1. And once again, I'll cross cancel. 21 and 3 both divide by 3. 1 and 7. So now I distribute the 7. 7 times 5x is a positive 35x. 7 times 1 is a positive 7. Now we go over to the other side. To make this consistent, I'm going to put the 21 first. So 21 over 1 times 3x plus 4 over 7. And again, we'll have the parentheses around the 3x plus 4. We can cross cancel 21 and 7. Again, both divide by 7, giving us 1 and 3. And we distribute the 3. So 3 times 3x is 9x. And 3 times 4 is 12. Now the fractions are gone. We're ready to start working on the rest of this equation. We still have to go through the steps. We combine what we can on each side. So on the left side, we have 6x and 35x, make 41x. We also have negative 9 and positive 7 makes negative 2. On the right side, there's nothing to combine. This is 9x plus 12. Next, we have to make sure the variable is on just one side. Well, here it's on both sides, so we'll get rid of the smallest one. That's the 9x. We'll subtract 9x. 41x minus 9x is 32x. Minus 2 equals 12. Now we're ready to solve. So we'll add 2. 32x equals 14. And we divide by 3. Not divide by 3, divide by 32. X equals 14 divided by 32. Again, we can just turn that into a fraction of 14 over 32. Both of those can be reduced by 2 to give me 7/16. X equals 7/16. Well, that one wasn't so bad, but occasionally we mix one in like this. Let's do 5x minus 3 over 4 minus 3x minus 7 over 2 equals 4x plus 1 over 4 minus 3x. So now here we have a common denominator. We have denominators of 4 and 2. So our least common denominator is going to be 4. So we're going to multiply both sides by 4. On the left side, the first part here is pretty standard. 4 times the 5x minus 3 over 4. 4 over 1 times 5x minus 3 over 4. Put in the parentheses here, but the 4's cross cancel, giving me 1 and 1. So that is just 5x minus 3. The difficulty comes in the second step. We have minus in front of this. So we have to treat that. This is 4 times that, 4 over 1 times. Remember, this minus in front meant it was a negative 1 times that. So times a negative 1 times 3x minus 7 over 2. So what I'm going to do is I'm going to combine the 4 times negative 1 first. This is negative 8 over 1 times 3x minus 7 over 2. Again, there's parentheses around the 3x minus 7. The negative 8 and 2 cross cancel. 2 divided by 2 is 1. Negative 8 divided by 2 is negative 4. And now we distribute the negative 4. So negative 4 times 3x is negative 12x. Negative 4 times negative 8 is a positive 28. That's the part that most people miss, is they keep that as a negative 28. On the other side then, we have 4 times 4x plus 1 over 4. So 4 over 1 times 4x plus 1 over 4. Well, here again, the 4's just cross-cancel, giving me 1 and 1. That's just 4x plus 1. And then we have negative 3x times 4x is a negative 12x. So now we're back to solving, working on the equation again. We'll start by combining what we can. We have 5x and negative 12x is negative 7x. Negative 3 and 28 is a positive 25. We do have stuff to combine on the right side now. 4x and negative 12x is negative 8x plus 1. Then we have to get the variable to one side. There's a variable on each side. The smaller one right now is negative 8x. They're negative, so the negative 8 is more negative, so it's smaller. So I'm going to add 8x to both sides. Well, negative 7x plus 8x is just 1x or just x plus 25 equals 1. And then we solve. Well, here we just have to subtract 26. We subtract 25. I don't know where the 26 came from. To get that x equals negative 24. We can run into some equations where we have no choice but to use that least common multiple. We might have equations like this. 5 over 2x minus 3 over x plus 7 over 2 equals 6 over x plus 1/2. So let's do this, plus 1/4. So here we have denominators of 2 and 4, and 2x and x. Well, I'm not going to worry about the variables for now. I'm going to just worry about the numbers. So I've got 2, 4, and another 2, and I'm ignoring the x's there. Well, for the numbers, that least common denominator is just going to be 4. For the variable, it's the highest power of the variable. Well, we just have x here, so just x. So now we're going to multiply both sides of this by 4x. So on the left side, 4x times 5 over 2x, 4x over 1 times 5 over 2x. Now we could do some cross-canceling here if you're good with that. Or we could do multiply it out and reduce. I'll multiply this one out and reduce. 4x times 5 is 20x. 1 times 2x is 2x. 20x divided by 2x is 10. Next we have 4x times negative 3 over x. So 4x over 1 times negative 3 over x. I can put the negative with the numerator or the denominator, just not both. So I'll put the negative with the 3 on top. And I'll multiply that out. 4x times negative 3 is negative 12x. 1 times x is x. Negative 12x divided by x is just negative 12. And then we have 4x times 7 over 2. 4x over 1 times 7 over 2. So we multiply that out. 4x times 7 is 28x. 1 times 2 is 2. Well, 28x divided by 2 is 14x, so plus 14x. On the other side, 4x times 6 over x, so 4x over 1 times 6 over x. If I multiply that out, 4x times 6 is 24x, and 1 times x is x. 24x divided by x is just 24. And then 4x times 1/4. 4x over 1 times 1 over 4. Well, the 4's just cancel out. That's just x. So now we've reduced that equation down to something we've seen before. We can combine on either side. On the left side, 10 and negative 12 make negative 2 plus the 14x. Right side, there's nothing to combine. Next, we need to make sure that the variables are on one side. Well, it's on both sides, so I'm going to subtract the smaller one, which is just the x. This is negative 2. 14x minus x is 13x. Equals 24. Then, we're ready to solve. So we'll add 2. 13x equals 26. And we'll divide by the 13. X equals 2. Now, I admit that's kind of an extreme example of an equation to solve, but we do run into them. If we get into labor mixing or solution rate mixing and stuff like that, it's a very common thing to have the variable on the bottom of a fraction. If you get into electronics, it's very common to have your variables on the bottom when you're combining parallel circuits. The next thing we want to look at then is working with formulas. So let's say I have a formula like, oh, my Fahrenheit temperature is equal to 9/5 times my Celsius temperature plus 32. Well, if I ask you to evaluate for C equals 20, all that's asking you to do is to substitute into this formula for C, put in the number 20. F equals 9/5 times 20 plus 32. So we would have to, the order of operations, 9/5 times 20 is 36. And then add 36 plus 32 is 68. Now, if I asked you to take that same formula, F equals 9/5 times C plus 32, but this time I asked you to find C when F equals, oh, let's go 63. So I would put 63 in here for F equals 9/5 C plus 32. And I would have to solve now for C. So we're just solving an equation. So we would subtract 32. 63 minus 32 is 31. Equals 9/5 C. And then we divide by the 9/5. That equals C over on the right side. 31 divided by 9/5. Make that 31 over 1 divided by 9 over 5. That'll become 31 over 1 times 5 over 9. 31 times 5 is 155. And 1 times 9 is 9. And then we have to divide that out. 155 divided by 9 give us a mixed number. 9 goes into 15 once. 9 with 6 left over. Bring down the 5. 9 goes into 65 7 times. That's 63. 2 left over. So that is 17 and 2/9. Sorry about that. I'm not sure why that went off. So anyway, that wasn't so bad if we were going to do that once. But if we had several problems where I was going to be given a value for F and solve for C, I would not want to have to go through that process of solving the equation time. So if I had F equals 9/5 C plus 32, if I was going to have to put in several values for F and calculate C, I would want to solve that for F. I'd want to not for F, for C. I'd want to rearrange it. So what I would do is get C by itself. I would subtract 32, just same steps I did up here once I put a number in, only I don't have a number for F. So I'd subtract 32 from both sides. F minus 32 is just going to be F minus 32 equals, the 32 is gone on the right side. We have 9/5 C. And then I'm going to divide by 9/5. Now remember, when we divide, we can divide every digit. So on the right side, the 9/5 cancels out, we just have C. On the left side, F divided by 9/5. Remember, dividing by 9/5 is the same as multiplying by 5/9. So F divided by 9/5 is just 5/9 F. Negative 32 divided by 9/5. Negative 32 over 1 times 5 over 9 ends up being a negative 160 over 9 minus 160 over 9. Now, when I get a value for F, I can plug it in and I can solve this rather quickly rather than having to solve the equation each time. Other formulas that we might want to rearrange. We might have just a simple area equals 1/2 base times height. And let's say we're going to be given the area and the base and we want to find the height. So we're going to solve for H. Well, I can multiply by 2 to get rid of the 1/2. So 2A equals B times H. And then divide by B to get rid of the B. So 2A divided by B is just going to be 2A divided by B, or 2A over B equals H. So it's just a matter of letting those variables stack up. One more formula that I want to show you before we hang it up for the day, body mass index. Your BMI is your weight divided by your height squared, and your height's in inches, times 703. So let's take a hypothetical person here who has a weight of 180 pounds and a height of 73 inches. So body mass index here would be 180 over 73 squared times 703. So again, you're just substituting in the numbers for the variable that they represent. And at this point, it's now just a calculator problem, really. Because we're down to 30 seconds left, I'll do it on the calculator. 180 divided by 73 squared times 703. And we get a body mass index of 23.75. Okay, that is our time for the day. So your homework out of the book, starting on page 60 through 61. 1 through 47, the odds, and 61 through 65, the odds. Make sure you do those word problems. Then also page 67 through 68. 1 through 27, the odds. And also I want to make sure you do 35 and 37. Again, make sure you focus on those word problems. With that, we are out of time. So you guys have a great day. Hopefully we'll see you all on Wednesday.